We designed Corvette for the driver. All of the technical innovations for 1992 are focused on enhancing that driving experience. This past summer, we invited members of the press from all over the world to Montreal to preview and test our 1992 models. Here's a review of the technical highlights we covered with the press and scenes of the testing that took place.
In 1992, ZR-1 continues its evolution as one of the world's most technologically advanced production sports cars. ZR-1's state-of-the-art LT5 engine, a new sophisticated acceleration slip regulation system, and an exclusive Goodyear GSC ultra-high performance tire design highlight its technical advancements for 1992.
In the old days, Corvette was very powerful and exciting. And part of the excitement was the mystique that its performance was on the edge. Today, Corvette is a sophisticated world-class car. It's earned a reputation for being remarkably well built, with performance as exciting as ever. And now the driver has a high level of control over that performance. All of us on the Corvette team take great pride in our relations with our customers. As a result, our customers have had an important influence in helping us define the Corvette.
The LT5 is a remarkable engine, yet the ZR-1 is still a car you can feel comfortable in driving around town. This versatility can be directly attributed to its design and construction.
The LT5's engine block, water pump, intake manifold, and cylinder heads are all made of lightweight aluminum alloy. Each cylinder head has dual overhead camshafts and 4 valves per cylinder.
The aluminum components offer several performance advantages. Aluminum alloy can be spec'd to tighter tolerances and dissipates heat more quickly than cast iron. You want both of these attributes in a high-performance engine. Of course, aluminum also weighs less and helps contribute to the ZR-1's impressive horsepower-to-weight ratio. Anytime you reduce mass, you help performance. The multi-valve head design and dual overhead cams make the LT5 a remarkably free-breathing engine.
To deliver a precise blend of air and fuel, the LT5 has 8 primary and 8 secondary aluminum induction runners, 2 per cylinder. Each runner is fed by its own fuel injector for a total of 16. Under normal operation, only the primary set of injectors is functioning. But when maximum power is required, the second set kicks in to give ZR-1 its legendary performance.
Using this bimodal system of operation, the driver can obtain the performance he needs when he wants it. During normal driving, the engine delivers optimum fuel economy while producing minimum engine noise.
The advanced design and technology of ZR-1's LT5 engine results in world-class performance specifications. 375 horsepower at 5,800 RPM and 375 pounds-feet of torque at 4,800 RPM. On the test track, ZR-1 goes from 0 to 60 miles per hour in just 4.3 seconds.
You might think that such a sophisticated engine made of lightweight materials would be somewhat delicate and require expensive and constant maintenance. Nothing could be further from the truth. The LT5 has proved its durability under the most demanding conditions imaginable.
In 1990, a ZR-1 with a stock LT5 engine established 6 world endurance records, including the 24-hour and 5,000-mile marks at average speeds over 173 miles per hour.
When you talk about technology and performance, nothing quite compares to the ZR-1. It's a Corvette, only more so.
This year, Corvette enters a new era of all-weather performance with the introduction of acceleration slip regulation, ASR. ASR goes beyond other traction control systems by providing complete drivetrain management.
Driving a high-performance sports car like the Corvette in inclement weather conditions such as ice and snow can be very stressful. The intent of the ASR system was to reduce that stress by enhancing acceleration and stability of the car under those conditions, such that the confidence of the driver was increased and the car could be an all-weather car. And we do this by controlling the torque applied to the road through the tire, by managing engine torque as well as brake intervention.
The brain of the system utilizes 3 microprocessors and a central electronic control unit that's located underneath the rear floor behind the driver's seat. The ASR electronic control unit constantly monitors drive wheel speeds, vehicle speed, the speed difference of non-driven wheels, the front to rear wheel speeds on the same side of the car, vehicle acceleration, and throttle position. This data is collected through speed sensors at each wheel. The same sensors are also used in Corvette's anti-lock brake system.
The ASR system controls torque in the engine in 2 ways. First of all, it modifies the spark advance, reducing engine torque output. Secondly, there is a throttle relaxer or throttle pullback mechanism that signals the driver it's operational through feedback in the accelerator pedal. The second stage of slip regulation is brake intervention. It helps maximize traction by automatically applying and releasing brake line pressure. Brake intervention does not activate at speeds above 50 miles per hour.
The driver can manually turn ASR off by using the button above the headlamp control. This should be done when both rear wheels are on a low traction surface like ice. Turning ASR off will allow the wheels to spin freely, letting them get through the snow or ice to the road surface.
We chose the term ASR as opposed to traction control because traction control is a generic term for technology that essentially means something to help you get unstuck. In our case, we wanted to tie it into a performance-related image such as acceleration slip regulation to make it consistent with the performance image of the great American sports car.
Tires have always played an important part in Corvette's performance. They put the power to the road.
Goodyear's Gatorback radials were first designed for the 1984 Corvette. They were based on the rain tires used on Formula One race cars.
In 1992, Corvette is once again moving the leading edge of tire technology with the introduction of its Goodyear Eagle GSC high-performance radial. This tire is available as original equipment exclusively on the 1992 Corvette and ZR-1. Its innovative tread pattern is designed to maximize both wet and dry performance. The pattern is not only directional, as the Gatorback was, but also asymmetrical, meaning that one half of the pattern is not mirrored on the other half. This allows us to put the maximum amount of rubber on the road at the outer edge of the tire.
When a car corners, its weight shifts to the outside. The GSC tread provides more contact area on the outer edge of the tire to enhance grip. In addition, the tread blocks on the outer edge are stiff for quick response and high cornering power. The inside tread blocks are narrower and more flexible for traction. The wide grooves in the inner portion disperse water from under the tread more quickly to reduce hydroplaning and maximize the tire's contact patch with the road.
Whenever you develop a tread pattern, there are always trade-offs between wet and dry performance. Indy cars run on slicks for maximum contact with the track, but they don't have to worry about running in the rain. The key for the street is to strike a balance, and the Eagle GSC is Goodyear's best design yet at maximizing both wet and dry performance. And at the same time, the tire delivers excellent ride quality and minimizes tread noise.
Every year you can point to a few new things like ASR that are dramatic leaps forward. But just as important is the continuous improvement, the evolution that has made Corvette the world-class performance car that it is today.
A significant refinement for 1992 is our update to the selective ride control that incorporates double digressive shock valving. Obviously, roads are not smooth. This refinement gives us a way to isolate the road without compromising the handling. Traditionally, there is a trade-off between ride and handling. Better control and handling used to be associated with a cost, and that cost came in ride quality. The double digressive shock valving allows us to soften impact without sacrificing the Corvette's handling. Ride quality is very important to the Corvette owners. This is why we've also added front spring isolators and lowered the front spring rates to help reduce harshness. Nothing on the car acts alone. The refinements to the suspension for 1992 is a perfect example of how we're always looking at the total package with an eye towards better meeting the needs of the Corvette owners.
For 1992, Corvette is again in a class by itself, incorporating the latest advances in automotive technology, yet still embodying the spirit and heritage that have made it the American classic.